Okay, welcome back. This is Mr. Hassan's Maths Channel. I'm now answering a question from the Cambridge 9709 syllabus, and this is a question from a paper 1, which is Pure Mathematics 1 from October-November 2011. It's paper 1, variant 1, question number 9, which is related to quadratics and also straight line graphs. So 9 part 1, we're told about a line which has equation y equals kx plus 6. Y equals kx plus 6. And a curve which has equation y equals x squared plus 3x plus 2k. And k is a constant. Okay, so part 1 says, for the case where k equals 2, the line and curve intersect at the points A and B. So we got to find the distance AB and the coordinates of the midpoint of AB. So for us to find the distance between A and B, and also the midpoint of A and B, we first need to find what the coordinates of the points A and B are. So let's first of all put k equals 2 into these equations. So, when k equals 2, we have the equations y equals 2x plus 6, and the curve y equals x squared plus 3x, and 2 times 2 is plus 4. So those are the equations of the line and the curve when k equals 2. This line and this curve intersect at the points A and B. We have to find the coordinates of those 2 points. So when we are trying to find where 2 lines or 2 curves or a line and a curve intersect, the algebraic way of doing so is to solve the equations simultaneously. So we got to solve this pair of simultaneous equations. One of them is linear, the other one is quadratic. Now there's various ways we could do that. Okay, but the simplest way of doing that is basically to substitute one equation into the other. Now some of you will be saying, we have to equate the 2 equations together. And that's what some of you write, x squared plus 3x plus 4 equals 2x plus 6. And that's true in this case, in any case where they're both equal to the same thing. So 2x plus 6 is equal to y, x squared plus 3x plus 4 is equal to y, so they're both equal to each other. And that's fine, but sometimes you don't get equations written in this form. Sometimes you have, for example, say the equation of a circle, like x minus 3 squared plus y plus 2 squared equals 15, something like this. And then how do you solve it like this? It's a big hassle to make this, for example, the y the subject of the formula, then equate those two, whatever's on the other side to 2x plus 6. That will look very complicated. So the best way to think about what you're doing here, so it will relate to every single type of question that you do, is not that we equate the 2 equations, but we substitute one of the equations into the other. So here what we've done is, basically we've taken this x squared plus 3x plus 4, because it's equal to y, and we substituted instead of this y, what y is equal to from the other equation. So you take one equation and you substitute the y with whatever y is in the other equation in terms of x. Then you have this equation where there's only one unknown and we can try to solve it. Okay, so for example, if you were solving this equation with this curve, with this circle, then what you would do is you'd just replace this y here with 2x plus 6, and then you can have an equation with just x's, then you'll solve it. Okay, so that's just a little side point to things that I hear students saying, and then they sometimes get confused when they have other situations. So think about this as not equating the 2, but substituting one equation into the other, replacing the y in one equation with what y equals in the other. That's a more kind of comprehensive way of thinking about what's happening here. So now we're going to solve this equation. We've got a quadratic equation. So we're going to try to attempt, first of all, to see if we can use factorizing, in which case we're going to be using what's called the zero product property. So we have to make sure it says equals 0. So we have x squared, you have 3x minus 2x, which is plus x, and you have 4 minus 6, which is minus 2 equals 0. So you have x squared plus x minus 2 equals 0. Now, can we factorize to solve this? It looks like we can. We have to find 2 numbers that have different signs. There's a 1 in front of the x squared, so I could just put x plus x minus. So the 2 numbers must multiply to give you -2 and add to give you +1. Well, that's +2 times -1 gives you -2, and 2 minus 1 is 1x, is 1, so therefore the coefficient of that will be 1. So that is the factorized form of this. Now what we can do is find the value or the values of x here. So now we can say that either by the zero product property, if two things multiply together give you 0, one of them must be 0 or the other one must be 0. So those are the possible values of x. When x plus 2 is 0, x must be -2. And when x minus 1 is 0, x must be equal to 1. So those are the x values of the 2 points A and B. They didn't tell us which one is A and which one is B. So I can just, let's assume, okay, assume x equals -2 is for A. Okay, is the x coordinate of A. So therefore, y is equal to, for the x coordinate of A. Now we can replace -2 in either of these two equations and we will get the same answer because they both intersect at that point. But of course, what is much easier is to use the linear equation. Less work to do. So you can replace the 2 here with -2. Sorry, the x here with -2. So we have 2 times -2 plus 6, which gives you -4 plus 6, which is 2. So we can say the coordinates of A are -2 for the x and 2 for the y. And we can say assume that x equals 1 is for B. So therefore the y coordinate of B is going to be 2 times 1 plus 6, which is, that's 2 plus 6, which is 8. So the coordinates of B are 1 and 8. Okay, so now we have got the coordinates of A and B. So you know the coordinates of A, -2, 2. We know the coordinates of B, 1, 8. So now we have to find the things they asked, which was the distance AB. So first of all, we want to find the distance AB. This is what this symbol means, is the distance between AB. And what we're going to use here is we're going to use the formula, which is based upon Pythagoras' theorem. Basically, as you'll see, this is like xa minus xb squared plus ya minus yb squared square root. Is basically the distance between the x coordinates and the distance between the y coordinates is basically the distance of the length of the two shorter sides, and the length AB is the hypotenuse. So I mean, if we just make a quick sketch just to illustrate what's happening, this is basically stuff from IGCSE, but just to recap, if this were the pair of axes, and we had -2, 2, and we have 1 and 8, okay, 1 and 8, somewhere up there, and we have this, and we want to find the length of that line. Okay, so we know that this is -2, we know this is 2, we know this is -1, and we know this is 8. So the length of that line can be found using Pythagoras' theorem. We can form a right angle triangle. Okay, and we can say that that distance here is the distance between the x coordinates, and that distance here is the distance between the y coordinates, and it's a right angle triangle. So this is the hypotenuse. So the hypotenuse is equal to the square root of the square of the two shorter sides, the sum of the squares of the two shorter sides. All right. So that's basically what we're doing. This formula is using Pythagoras' theorem, in case you didn't realize. So this means the length of the line segment AB is equal to the square root of, you're going to have -2 minus 1 squared plus, you're going to have 2 minus 8 squared, which gives you, that's going to be -3 squared, which is 9. When you square a negative number, it becomes positive, and this is going to be -6 squared, which is going to be plus 36. When you square a negative number, becomes positive, so that gives you the square root of 45. Okay, so that is the exact length AB. All right, now the question did not state find the exact distance. Okay, it does not state that in the question. So as the question did not state, okay, to give the answer in exact form, then you could write your answer in decimal form, rounded to three significant figures. So you could say the square root of 45 is equal to 6.708. So you could write your answer as 6.708 and then round it to three significant figures, because the question, the instructions do say non-exact answers should be written to three significant figures. But you could also, in AS level, you could leave it as insert form. So you could leave it like this, but I'm not very comfortable leaving it like this, because this is not actually considered simplified. To write something in third form in its simplified version, all right, simplified third form, you have to take out any perfect square factors from this. So for example, here we know that 9 times 5 is 45. So this is going to be like the square root of 9 times the square root of 5, because we know that the square root of a times b is the same as the square root of a times the square root of b. So now the square root of 9 is 3, so this is 3 root 5. So this is a better way of writing your answer for if you're going to leave it in exact form. Although the mark scheme accepts this, it accepts you to round it to 3SF, and it also accepts this, of course, right? Now, this I think would be the best way to leave your answer, to be honest, because that's in simplified third form, right? So sometimes they might ask you to give your answer in simplified third form, so you should know the difference between these. This is rounded to 3SF. This is in third form. It's not simplified. Now, some exam boards might not accept that, right? But in Cambridge, they would accept this and this if the question didn't mention anything in more detail. But I would just be on the safe side. If you can put it in exact form, put it in simplified third form, and you'll notice that your calculator gives you that. So when we pressed this, root 45 equals, it gave us 3 root 5. Okay, so the calculator normally will give you answers in, like if you put this in your calculator, it would come out in simplified third form. If we had just done that straight away, we would have got minus 2 minus 1, which is minus 3 all squared, which is 9, plus 2 minus 6, which is minus 6 all squared, which is 36. The minus becomes positive because you're squaring it. And when you press equals, it gives you the answer in simplified third form. Anyway, all right, but that's just a little side point there. So that completes question 9, part 1, which is basically the first half of it was solving quadratic simultaneous equations, right? The second part was it more to do with straight line graphs, finding the length of a line segment, and we haven't finished actually. I just realized finding the midpoint. Don't forget this type of question. Sometimes it's easy to forget something. In some questions they'll say part A, find the distance AB, and part B, find the coordinates of the midpoint. It makes it clearer here. It's that sometimes you might forget about the midpoint. You've done the first part, which I almost did. So now we've got to find the midpoint of AB. Now the midpoint between 2 points, so we have the points A, minus 2 and 2, and B, 1 and 8. Now the midpoint between 2 points is basically the average, okay, of the x coordinates and the average of the y coordinates. So it's basically exactly halfway between these two and exactly halfway between those two, somewhere over there, right? That will be the midpoint. Okay, halfway between these 2 points, halfway between the x values, halfway between the y values. So how do you find halfway between 2 points? You add them together and divide by 2. So without having to draw the diagram, you can say the midpoint, we'll call it M, is going to be minus 2 plus 1 divided by 2. That's for the x coordinate. And for the y coordinate, it's going to be 2 plus 8 divided by 2. So you can say the midpoint, therefore the midpoint is going to be minus 2 plus 1, which is minus 1 over 2, which is negative a half, and 2 plus 8, which is 10 divided by 2, which is 5. So those are the coordinates of the midpoint. And that concludes question number 9, part 1. So as I mentioned, the first part is about solving linear and quadratic equations simultaneously. The second half of this question was more to do with straight line graphs, finding the midpoint and the length of a line segment. And now we're going to go on to part 2. So part 2 says find the 2 values of k for which the line is a tangent to the curve. So here we have the information from the first part. So it's related to this sentence here from the first part of the question. So we're going to leave these in terms of k, and we've got to say or find the values of k for which this line and this curve, okay, where this line is a tangent to that curve, right? So this curve would look something like this, is a quadratic. And this line, depending on the value of k, if it's positive or negative, say it's positive, it's possible it could be negative or positive. There could be different values of k. So that is a tangent. That's when a line is a tangent to the curve, where it just brushes past it at a certain point. At the point where it touches the curve, okay, there they have the same gradient. This is the tangent to the curve at that point. Now, what we should understand is that when you have a curve and you have a straight line, then there are different possibilities for the number of times they intersect. It could be that they never intersect, in which case the curve curves up before it touches the line. Or it could be that they intersect in 2 points. Okay, like when k was equal to 2 in the first example we saw, we found that they intersect in 2 points. Okay, now this is the case where they intersect or they just brush at 1 point. So if I try to solve simultaneously the equation where this is equal to that, okay, where I substitute this into that equation, basically when I try to solve these two equations simultaneously, and I know that the line is a tangent to the curve, well, I know that that equation should only have one solution, one real root. Okay, it's called a repeated root. Okay, and that is because it only touches the curve at 1 point. So the solution to y equals kx plus 6, simultaneously with the curve y equals x squared plus 3x plus 2k, there will only be one solution if this line is a tangent to the curve. So again, we're going to solve these two simultaneously. So I have these two equations here, x squared plus 3x plus 2k. So this time k is not equal to 4. It's a different situation. So to solve them simultaneously, again, I will replace this y with x squared plus 3x plus 2k, and that's equal to kx plus 6. So I'll replace this y with that. Okay, and now I have a quadratic equation. It looks a bit different than before because we have this constant k which we have to find. So let's just rearrange this so it says equals 0 again. So you have x squared, and you got plus 3x minus kx, and plus 2k minus 6 equals 0. Now what I'm going to do here is I'm going to take out this x as common. Right, so I'm going to take out this x as common, but I'll write the bracket on this side. So it's x times 3 and x times minus k. That's 3x minus kx. And here I've got 2k minus 6. Now this whole thing is my constant. This whole thing is a constant. K is a constant. So this is like the x squared term, this is the x term, and this is the constant term. And we know that that's equal to 0. So now, how do I find the value of k? Well, what we should understand is, and it's very important this, okay, that we know that this only has one solution. Okay, if y equals kx plus 6 is a tangent, then only one real, or you can say repeated root, one real repeated root. Okay, one real repeated root, you could say. Okay, there's only one root, there's only one real solution if x equals kx plus 6 is a tangent to this curve. This equation that's formed when we simultaneously try to solve it will have one solution. Now there is something in the quadratic formula which we should all know. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. There's something in this formula that determines or discriminates between how many solutions a quadratic equation will have. All right. Now this is the quadratic formula. When you have an equation ax squared plus bx plus c equals 0, A stands for the coefficient of x squared, B stands for the coefficient of x, and C stands for the constant. So when you substitute these values into this quadratic formula, what you'll find is the thing that will determine or discriminate between how many solutions the quadratic equation will have is this b squared minus 4ac. If b squared minus 4ac is positive, you'll end up with minus b plus or minus some value over 2a. So you'll have minus b plus something over 2a and minus b minus something over 2a. So you'll get two different answers, two real roots. If b squared minus 4ac is negative, well, this thing will be undefined. The square root of a negative number is undefined. You have no real root. Okay, it's an imaginary number, which we'll get to when you get to A level, A2 for the ones taking Cambridge, right? Or further maths if you're taking some other boards. So, but for now, P1, there's no real root, there's no solution. Okay, when this is negative. Okay, because if you try to find the square root of a negative number, as you know, your calculator will say math error or will have an I in it, which means the imaginary number. So we're only talking about real solutions here. So now, the third scenario is when b squared minus 4ac is equal to 0. Now, if that's equal to 0, well, the square root of 0 is 0, and you're left with minus b plus or minus 0. So basically, you're just left with minus b over 2a, which is just one answer. So that is the case when b squared minus 4ac is equal to 0. That's when you're going to have one real repeated root. Okay, you'll have one real repeated root when b squared minus 4ac is equal to 0, when the discriminant is equal to 0. So here we have our a is the coefficient of x squared, which is 1. Our b is the coefficient of x, which is 3 minus k. And our c is our constant, which is 2k minus 6. So if we take b squared minus 4ac, and we'll see what it equals, hopefully we will have an equation now which we can solve for k, and that will be the value, or those will be the values of k for which this will only have one real root. So we're going to have b squared, which is 3 minus k squared, minus 4 times a, which is 1, times 2k minus 6. Okay, that is the discriminant, b squared minus 4ac. So let's see what that, we know that has to equal 0. B squared minus 4ac has to equal 0. So this is going to, if we expand this square bracket, we square the first term, we multiply these two together and double it. So that's minus 3k doubled is minus 6k. And then we square the last term, that gives us plus k squared. And then you're going to have 4 times 2. Be careful, very careful here. It's very easy to make a mistake here. So you have 4 times 1, which is 4. So you have negative 4 times 2k, which is minus 8k. And negative 4 times negative 6, which is plus 24, equals 0. So here we have a quadratic equation. We have k squared minus 14k and plus 24 plus 9, okay, which is 33, equals 0. So what are the values of k? Well, this, I think, can be factorized. 33 is 3 times 11, and they both have to be the same sign. They both have to be negative. Yeah, so if you want to solve this equation here, we're going to have both of them have got to be negative, because you're going to have negative times negative is positive, and negative plus negative is negative. And the two numbers must be 11 and 3, and that works out. That's positive 33 when you multiply them, and negative 14 when you add them. So those are the solution. Those are the the factors. So therefore we can say k minus 11 equals 0. So k equals 11, or k minus 3 equals 0, in which case k equals 3. So those are the two values of k for which this line and this curve, this line will be a tangent to this curve. Okay, so when you have y equals 11x plus 6 and x squared plus 3x plus 22, or when you have y equals 3x plus 6 and y equals x squared plus 3x plus 6, that's when you will have the situation of this occurring. The line will be a tangent to the curve. All right, so that concludes question part 2 of this question 9 from the October-November 2011 paper. And this part 2 is related again to quadratics and discriminants. Okay, so the majority of this question is from the chapter of quadratics, and the part of it is from straight line graphs. So I hope that was clear. There's some basic important concepts which some students do have issues understanding, and it's important for us to try to understand what we're doing always. So if you would like to see other questions from this paper, then I will collate together all the questions I do from this particular paper, October-November 2011, variant 1, paper 1, from the Cambridge syllabus. I will collect them in the playlist that will be over here. That's for the questions from this paper, right? So if you see a question that's not in that playlist and you want me to answer it, that's from this paper, just send me a request and I will do so. Just write a comment on one of the videos and I will try to do so as soon as I can. And in the playlist that you will appear down here, you will find questions that are related to the topic of quadratics. Okay, so I will collect all the quadratic questions topic-wise in this playlist over here. So this question and other questions like it which deal with quadratics will be that playlist. In the playlist that will link in this region here, you'll find those questions which are related to straight line graphs, because part of the question was dealing with straight line graphs. I'll also put it in that playlist as well. And if you would like to watch a video, or no, in fact, if you'd like to subscribe to my channel, click on the link over here and you would see a card that's been appearing in this video, and it probably will appear around now as well, that you can click on, and it will take you, this link will take you to a video which will explain how to use my channel to find the thing that you're looking for, depending on what exam board you're doing or what level you are at. You can click on that and it will help you, it will show you how to navigate my channel efficiently. Thank you for watching and see you soon.